Alright, so to start off this video, we're actually just going to dive right into some examples. And I actually want you to try to answer these questions to the best of your ability, questions 1 through 3, completely on your own using your current knowledge. And assuming you have answered the questions, let's go through this together. So question 1 says, if we have a system of equations with two parallel lines, do they have a solution? And could they have more than one solution? Well, the short answer is no, that they would not have a solution. And that is because parallel lines never intersect. Although there is an exception, and that is unless we have the same linear equation with the same slope and y-intercept. Now, and that is because technically, if you have the same linear equation, technically it is parallel with it. So it's technically parallel, so that's why I said there is an exception. But if you don't have the same linear equation, then there's no solution. But if it's the same equation, then you're actually going to have, hint, hint, infinite solutions because it's on top of it. All right. For number 2, the question is, what if we have a system of two perpendicular equations? Would they have any solutions? The answer to this is yes. Parallel lines contain one solution. And that is because they intersect. And they specifically intersect once. Taking a look at example 3 or question 3, we have how might you be able to tell if you have infinite solutions or no solutions to a system of equations? And how might you be able to tell if you only have one solution? Well, the first thing is if you have the same slope, if both lines have the same slope and y-intercept, then what's going to happen is you're going to get, here I'm actually going to write an arrow. Then you're going to get infinite solutions. Now, if you have the same slope, or if both lines have the same slope, but they have a different y-intercept, that means you're going to have no solutions. So for 1 and 2, notice that I said both of them have the same slope. So rules 1 and 2 account for parallel lines, or a system of parallel lines. Now for rule number 3, if they have a different slope and a different y-intercept, you will have exactly one solution. All right, so let's start by working. For example 2, we are told to solve the following systems using any of the 3 methods we have learned. Also determine if the equations are parallel. We don't need the ors. Also determine if the equations are parallel, perpendicular, or neither. So looking at example 4, we have y equals 1/4 x minus 3 and y equals 1/4 x minus 1. So looking at this, right, just by looking at this system of equations, I can tell right away just by looking at it that it has no solution. And I can do that because looking at the equations, we have the same slope and a different y-intercept. So that means we have, just by looking at this, I can tell automatically that our lines are parallel. That I can tell right away that we have parallel lines. And do parallel lines ever intersect? No, they don't intersect. So I can tell automatically just by looking at this that this system doesn't have a solution. But let's say we couldn't tell that right away. Let's solve this. So because both these equations are set equal to y, I can plug one of these equations in for y. So I'm going to plug in this top equation right here and for y right here. So I'm going to say 1/4 x minus 3 equals 1/4 x minus 1. Now to solve for x, I'm going to subtract 1/4 x on both sides of this equation. These x terms here cancel. These x terms here also cancel, so we get -3 equals -1. Well, this makes sense. We have no solution here because -3 does not equal -1. So that's your answer. There's no solution to this system of equations. All right. Looking at example number 5, we have y equals 2x plus 3 and y minus 2x equals 3. I encourage you to pause the video and try this example on your own. And assuming you've worked through it, let's go through it together. So automatically, seeing this, what I want to do is because this first equation here is set equal to y, I'm going to want to use substitution. And I'm going to plug in the expression 2x plus 3 for y because it's set equal to y. So doing that, we have y, which is 2x plus 3. And I'm going to carry down that -2x, and we're going to set this equal to 3. Now to solve for x, let's combine our like terms. So we have 2x and -2x. Uh-oh. That cancels. The x terms cancel, and we get 3 equals 3. Now, recall, what does that mean when we get a true statement, when we solve a linear equation? That means we have all real solutions. So what might all real solutions mean in this case? Well, in this case, that means that you have infinite solutions. You have infinite solutions to this linear equation. Now, looking at the system, this makes sense because this equation here, if we were to convert this to slope-intercept form, y minus 2x equals 3, if you add 2x to both sides, this is actually the same equation as this equation. So that's why we got this true statement, because these two equations are the same exact equation. So that's why we got infinite solutions for this system. So we can write this as y equals 2x plus 3. And then if we convert this equation to slope-intercept form, we get y equals 3 plus 2x. And even though this 3 goes over here, this 3 is positive, that 3 is positive, this 2x is positive, and so this 2x. So these two lines are the same exact linear equation, and because they're the same, these two lines are technically parallel, even though it's the same line. Alrighty, looking at example number 6, we have this system yx equals 2 and negative yx equals 2. So to start by solving this system, well, we have yx and negative yx, and since this y and this x is being multiplied and this y and x is also being multiplied, these two are like terms. So what we can do is we can right away just combine like terms with the system. So positive yx and negative yx cancel. We get 2 plus 2, which is 4. And we're going to set that equal to, well, since these canceled, 0. And, well, 4 does not equal 0. So we have no solution. Looking at example number 7, we have the system x equals 2 and y equals 2. Well, for this example, so we've learned 3 different methods, right? We've learned elimination, which is what we did up here. We did here. And we also learned substitution, what we did here. But we also learned in the very beginning of this unit, we learned how to solve systems by graphing. So this example, actually, it happens to be best to solve the system by graphing it. So I'm going to draw out the x and y axis. And we're going to go, I'm just going to do 2 dashes on each. So let's first start off by graphing x equals 2. Now x equals 2. Remember, that's on the x-axis, and we're going to graph directly when x is 2, so that's right here. And remember, when we have an equation where we have x set equal to a number, that means that we have infinite y values, so our line is, we have a vertical line going up and down, like so. Now for y equals 2, I'm going to graph that using this blue color. And y equals 2, that means that we're going to cross through the y-axis when y is equal to 2. And we're going to have infinite x values, which means we're going to have a horizontal line. Now, what is our solution to this system? Well, it's right here, where these lines intersect, and they intersect at the point 2, 2. So that's our solution to the system. 2, 2. And then we also here, we need to determine if these are parallel, perpendicular, or neither. Well, since these two lines cross through, we have a vertical line and a horizontal line, we know that these are perpendicular. Lines. So for the last example, I encourage you to pause the video and try it on your own. So solve the system and then determine if the lines are parallel, perpendicular, or if they aren't parallel or perpendicular. And assuming you have given this a go, let's work through this. So here we have a 3x and a negative 9. So we have 2 positive x terms and 2 negative y terms. So what I want to do is I'm going to multiply this top equation by some negative number. So one of our variables cancel. Why is it? Oh. So we're going to multiply it by a negative number. And let's say I want to cancel out the variable x. Well, to get 3 to 12, I'm going to need to multiply the top equation by 4, specifically negative 4. So now I'm going to distribute in this negative 4 to all these terms. So we're going to get negative 4 times 3, which is negative 12x. And then we're going to say negative 9y times negative 4 is positive 36y. And we're going to set that equal to negative 4 times 2 is negative 8. And then we're just going to bring down the second equation here. So we're going to have 12x minus 36y equals negative 8. Well, now let's combine like terms. So our x terms cancel, and our y terms also cancel. So on this side of the equation, we're going to get 0. And that's going to be equal to negative 8 minus 8, which is negative 16. So since 0 isn't equal to negative 16, we know that the system has no solution. And now our last step is to determine if these two linear equations are parallel, perpendicular, or neither. Well, because we have no solution, the only option we can have is that these lines are parallel. Now that is because, recall, parallel lines never intersect. And if these lines weren't parallel, then we would for sure either have at least one solution or multiple solutions, or sorry, infinite solutions. But since we have no solution, that tells us automatically that these lines are parallel. And if you wanted to, I encourage you to actually convert both this linear equation and this linear equation to slope-intercept form, y equals mx plus b. And if you do that, you would realize that you actually get you'd get two lines with the same exact slope, just different y-intercepts, which that is the definition of what parallel lines are.